Okay, we're doing the example of signal timing design, and this is the intersection which was given. The lanes and the speeds and the demand flow rates were given for each movement. Okay, so the first thing which we did was check the left turnings. Okay, and the left turnings were protected in this case because of the speed. Okay, speed is 45 miles per hour higher, you have to make the left turning protected. Then we have to identify the lane groups. Okay, the lanes which have same movement. Okay, here none of the lanes had the same movement, so we had to divide them one by one. Okay, the number of lanes and the number of lane groups we have. Then we converted the demand into demand flow rate, dividing by peak hour factor. One step which we didn't have to do was convert it to passenger cars, but otherwise you would have to divide it by the heavy vehicle adjustment factor as well. Okay, once you did this, then you have to calculate once after converting it to flow rate in passenger cars per hour, then you have to assign the flow rate for each lane group. Okay, so for example, if a lane has two movements, you will add the flow rates of these two movements. Okay, if a lane has if a movement is more than one lane, you have to divide the movement into those lanes and so on. So we did this. After that, you need the saturation flow rate. Okay, you will divide the saturation flow rate for each lane group. Okay, sorry, you will divide the demand flow rate for each lane group by its saturation flow rate. Okay, and this is what we got in the end. Okay, if you add all the V by S ratios, you are getting more than one. That means you cannot have a separate phase for each lane group. You have to combine some of them. Okay, and then we discuss the phasing plan. You can have different phasing plans, and your purpose is to minimize the summation of V by S ratio. You want to keep it as low as possible. Okay, so they tried putting all the movements from each side together. Then they tried the movements with V by S ratios closer to each other together. Okay, and then in the end, the last trial was, okay, we are putting them together, but still there is some difference, so the lane group which needs more time, extend it to the other phase as well. Okay, so this is how they found. And how do I know that my trials are working? I look at the V by S ratio. If it is decreasing, then something is working. Okay. The next thing is to find out the yellow and all red time. We have equations for that, and they depend upon the road geometry, dimension of the road. So they will be different for each side. Okay, and they also depend upon the speed as well. So wherever the speed is changing or the dimension is changing, these values will be recalculated. For lost times, I've already explained it, and they have given us some recommended values. 2 seconds. Okay, they are saying 2 seconds for each lost time. Total lost time for each phase will be 4 seconds according to their recommended values. Okay, so we did this. Then we have to select, and we already know the number of phases we have. So for each phase we have 4 seconds. Then multiply by the number of phases, you will get the total lost time. Then you have to decide the V by C ratio. Okay, and it is between 0.8 and 0.95, and I mentioned that this value should be higher than summation V by S ratio. Okay, not even close. Then we have two equations for cycle lengths. Using those two equations, we calculate the cycle length. Then we round up the values. From the cycle length, subtract the lost time, you will get total effective green time. Then total effective green time is divided according to this. This is the total effective green time you have. This is the effective green time for each phase. So total effective green time multiplied by V by S ratio of the phase divided by total V by S ratio. Okay. How you find out the total effective green time? Once you know the total effective green time, you can calculate actual green time. Okay, so we did up till this part. Okay, and in this calculation we had some overlapping phases. We have some overlapping phases here. Okay, so these, for example, this one, take this one, we have overlapping, right? Okay, so this one will need more time, this one will need less time, but actually they are together. So you have to increase its time, right? This one time of this movement. Okay, so you have to make this adjustment by looking at the phasing diagram. Okay, what do we have here? We have the green time for every movement according to each cycle length. Remember, we have two equations for cycle length. So we have two cycle lengths and we did the calculation, or they did the calculation for both of them. Okay, for both the cycle lengths. The last step is pedestrian check. You have to check if the timings are enough for the pedestrians or not. Okay. Now pedestrians can either cross this side or this side, east west or north south. Okay, when they are crossing in this direction, north south, they need green for what?
For north south.
North south. Somebody said east west. You said it. Somebody. You said it. Yeah? Means you. Okay. Okay. So if you are the pedestrian, you can go ahead, no problem. Okay. We'll have a class in your memory. Okay. But anyways, so he will go in this green, right? Okay. So this time, the time of this movement should be enough for pedestrian to cross this road. Okay. And same thing here. The time for this movement should be enough for the pedestrian to cross the north-south road. Clear? Okay. Now the dimension of the road. I should know the dimension of the road, right? Okay. This will come from where? Lane width and median. How many lanes? 3. Each lane 12 feet. And we have a median? Yes. How much is the median? 5 feet. So 12 into 3 plus 5. For this road, how many? 3 plus 2? 5 lanes. Again, each lane 12 feet. So 5 into 12 plus 5 feet of median. So you know how much pedestrian has to travel. Okay. Now. Yes. Yes. Okay. Now. No. This is how you calculate the required time of pedestrian. Okay. This one has a range 5 to 7 seconds. Okay. If you want to be on the safe side, you should take 7 seconds. Okay. And this one, W means the width he has to cross. The width of the road. Okay. So different for each side. And this is the speed of the pedestrian, which is recommended here. How much? 3.5. Okay. This is higher than normal. Normal is around 3 feet per second. Okay. Where we can use it? We can use it here. Okay. If you believe this value is not suitable for you, you can calculate. You can do the same thing for this thing as well, for TW as well. W upon speed of pedestrian. But which is speed of pedestrian? Normal. Okay, not this one. This is higher. This is the end when the signal is flashing. Okay, so the pedestrian already has warning that the signal is about to close, so he will go faster. Okay, so this is the, but right now we are taking the recommended value, which is in this range. Okay, so 5 to 7 seconds. Clear? For this one, I'll take for which side? If it is east-west, then I have 3 lanes plus 5 feet, right? 3 lanes plus 5 feet. If he is crossing the north-south direction, 3 lanes plus 5. How much? 41 feet. You were doing it like this. Very good. Do up to 41?
Yeah, do that.
He can do it, I know.
Okay, man.
Yes. So, okay. So 41 upon 3.5. Okay. So this, whatever you want to take, and this one be 41 upon 3.5. This is already in feet per second, so no need for conversion here. Okay, so this will give you the time required by the pedestrian to cross the north-south direction. The north-south direction. Okay, for the east-west direction, I'll take 5 lanes. Okay, east lane 12 feet, 5 lanes.
12 by 5.
How much?
12 by 5, 16.
See, plus 5 feet of median.
65.
65. Okay, so then I will take 65 upon 3.5. Clear? Okay, so for this direction, TW plus 41 upon 3.5. For this direction, TW plus 65 upon 3.5. Okay, now let us see what they have. Okay. So this is, now you can see here they have calculated one time for east-west direction and the other time for north-south direction. Okay, and they are checking it against the which movement?
East.
No, yes, eastbound, and they are also checking it against the westbound as well, right? Okay, eastbound as westbound. But which movement? I have eastbound, for example, left, and this is what? Eastbound? Through. Okay, so we always check with the through movement. Okay, if the left is separate, like here it is happening separately, right? Left has separate time and through has different time. But even if they are, if they are happening together, then no problem. But if they are happening separately, like here, so you will check the time against the through movement. Okay, so we are not checking against this one, we are only checking against the through movement. Okay, but it's still required time is 16.7 seconds for crossing the north-south direction. North-south direction. Okay, so he will either cross with the with the west movement or the east movement. He's crossing like this. He's crossing like this. Okay, he's crossing in the east-west direction. He's crossing in the north-south street. Okay, so he will either cross with the west straight movement or with the east straight movement. Okay, so what is the timing for the west movement? 22 seconds. From one cycle length, and from the other cycle length it is 27.7 seconds. How much time the pedestrian needs? 16 points. No problem. Okay, same thing here. From one cycle length 28, the other one almost 36, and he needs only 16 points. Okay, for the when he is crossing vertically. Okay, so he is crossing the east-west street, so he will cross with the north-south, right? Okay, so I'm checking with north-bound through and southbound through. He needs how much? 21.6 seconds. The timing for southbound 24 and 31, no problem. For north 24 and 31. Clear? Okay. Any problems? Any questions?
There's a right turn.
There is the right turn. There is the right turn.
Do you then consider?
No. Okay? Because if you consider it like this, then there will be no time, no safe time for the pedestrian. In the end, it depends upon the chance. Like, yes, he will go in this direction with this movement when he gets the chance. Okay? There's always this, because pedestrians they are not bound by the signal. They are not bound by the signal. So they may actually cross when this movement is red instead of green. They may actually cross in that time when they feel they have the chance. Okay, so this is like we are just providing them one phase in which they can cross for sure if they have the chance. Okay, if they don't have the chance, for example, this signal is green. Okay, but there is somebody turning right. Okay, so now they don't have the chance, so they will wait. Okay, after the right signal changed to some other movement, now they will wait for another cycle.
I mean, we didn't provide any extra time for the right turning.
No. In this case, it was permitted. Right turning is normally permitted unless you have some crashes happening or something, some other special case. Okay. Okay. Another okay. Another example. So we have now again two streets are given. Okay. You can see the movement for each one of them, and you can see the saturation flow rate. Okay. Saturation flow rate is given in passenger cars per hour. Okay. For our convenience, the flow rate is also given in passenger cars per hour. Okay. So the first step is already done. Okay. The first step was convert everything to passenger cars per hour and flow rate. That is already done. Okay. If it was not done, then you have to do it. Okay. The first thing is we decide about the left turnings. Okay. The left turning should be protected or permitted. Okay. If they had given us the speed of any road, so any road having a speed of 45 miles per hour or higher, we would say that it is protected. Okay. But in this case, speed is not mentioned. So I cannot use that criteria. I'll use the numbers then. Okay. So for example, I have to decide about this left turning. Okay. So I'll take the product of 138 and 920. Okay. And how many lanes I have? 2 lanes for this movement. Okay. So for two lanes, if you want to decide whether this left turning should be permitted or protected, so left turning multiplied by the opposite through movement. Okay. And then you look at how many lanes you have for the opposite movement. How many lanes I have? 2. Okay. So for 2 lanes, this number should be less than 90,000. If it is 90,000 or more, then you have to make it protected. Okay. For 1 lane it is 50,000. The numbers are given. Okay. For 1 lane it is 50,000. But right now we have the case for 2 lanes. So you can see in all directions I have the same lanes, right? Okay. So in all directions I will do what? Left turning multiplied by opposite through. Okay. And the number should be 90,000 or less than 90,000. Less than 90,000. Clear? If it is less than 90,000, we make it permitted. Okay. 90,000 or more, we make it protected. Clear? Okay. So this has been done. You can see that the calculations are very long. That's why I'm just going through them. Okay. If I leave it up to you guys, then you know what to do. You got to start counting on fingers. Huh? Okay. So you can see it's done here now. Okay. For the eastbound and westbound, it is protected because in both cases you can see the number is more than 90,000. Okay. For north and south, the number is less than 90,000, so it is permissible. Okay. Meaning what? Meaning I can consider a separate phase for left turning for the east-west directions. Okay. I can put them together as well, yes. But I can consider a separate phase for left turning for east-west direction. For north-south, I don't have to. Okay. I just consider what? Straight. That's it. Clear? Okay. No phase required for left turning. This is what it means. When it is permissive, no phase required for left turning. Okay. So left turning is with the straight. Clear or not? Okay. Okay. Next thing we do is identify the lane groups. Lanes having the same movement. Again, we have the same problem. We don't have any lanes which have exactly same movement. Each lane is different, right? Each lane is different from the other. Okay. They have shared movement but not the same. So this has a shared movement, but this one has a right turning as well. Okay. You cannot put them in the same group. Okay. So I have 3 lanes, I have 3 groups. Okay. And again, for every direction, same. Clear? Okay. Then the next step, for each lane group, find out the flow rate. For each lane group, find out the flow rate. The flow rates are already given. So what do I do now with these values? Oh, done. So what do I do with these values now?
The flow rate for each
group,
lane.
for each lane group.
For each lane group, yes. Okay, so for example, let's do it from here. So I have this lane group eastbound, okay, I think it's number 3, okay. So this one has which movement? Left turning, which is 138. So flow rate for this movement is, for this lane group is 138, okay. Now this one has a straight, okay. Straight is this one. Can I put this value here? Can I say this is 1007? Why not? Because it is sheared. Okay, so I have to divide it. Okay, and for division I will apply the same approach which I used in the previous question. Okay, this one will have less and this one will have more. Okay, out of 1007, the one which is exclusive will have more and the one which has shared will have less. Okay, and I'm using the same ratio, 45-55. So 55% of 1007 in this lane, the remaining in this lane, and this line will also have what? The right. Okay, so this one will be 0.55, 55% of straight only. This one 45% of straight plus the right. Clear? Okay, and this will be happening in all directions, same. All directions you have the same lane groups. Okay, clear? And they have given us the saturation flow rates as well. Okay, so this is saturation flow rate for a left turning lane. Okay, so it will be applicable here, 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 these lanes. Okay, then I have saturation flow rate for through lane only, which is the middle lane in all directions. Okay, this lane is through, right? So this one I have a saturation flow rate of 1600. Clear or not?
After we multiply by 155?
No, this is saturation flow rate. That was demand. This is saturation flow rate. Okay, you didn't open your coffee. Take a sip. Still sleeping. Take. Okay. Okay, so all middle lanes 1600. Saturation flow rates. Okay, saturation flow rates. And then the this one has how much? Tell me, saturation flow rate for the last lane, the right hand side lane. What value for the right hand side lane? Through and right. Okay, so this one 1600. Clear? They have given us a whole table, but we will only pick the values which are applicable. Okay, so through is applicable, left is applicable, through and right is applicable. The others are not applicable. Okay, so pick from this table the saturation flow rate for each lane group. Okay, so we have 1400 for left turning, and the other two have 1600. Okay. Okay, this is the flow rate for each lane group. Okay, the demand. Okay, the demand for each lane group coming from the movements. From these values. Okay, this is demand and this is saturation flow rate. Clear or not? Huh? Sure. Okay. So this is coming from here. Saturation flow rate I just picked from the table. Okay, and then we take the ratio. V upon S for everything. Clear? Any question? Okay. Again, we can do the exercise. Add all of them together. When you add all of them together, you get more than 2. What does it mean? Obviously not okay. What does it mean? We cannot do what? Huh? Yeah, you cannot have each one phase for each lane group. You cannot have this. Okay, so you have to merge them together. Okay. Huh? Yes, me.
It's nice.
Okay. So in the previous example, we discussed the trials. Okay. Put all the movements of one side together, then put the movements which have the same V by S ratio together, and so on and so forth. Okay. Here we have the advantage in the north side direction that the left turning doesn't require a phase. We said it is permissive. Okay. So in that case, then we can let them together, go together. There is no problem. So because right turning is already permissive, and left turning also is permissive. So what is left now? Through. And 2 through movements can go together, no problem. 2 through movements will go together. Now what will happen with right and left? Okay. People will go right and left when they have the gap, the chance. Okay. Clear or not? Okay. Anyways. So this one is 0.25. Okay. Now which one is 0.25? Let's look at it here. Which one is 0.25? Out of these 3, I picked 0.25, the higher one. Okay. And same thing for the north side as well. Okay. You pick the higher one. There. Okay. But if you look at the north side, it's 0.3, right? Okay. From the 3 movements at the north side, the higher one is 0.3. The 3 movements on the south side, the higher one is 0.25. Now, are these movements happening together? They are, right? They are overlapping. Okay. So in the end, I designed for what? I designed for 0.3 because all 6 of them are together. All 6 movements are together, right? So in the end, I will just design for what? 0.3. Okay? Clear? Same thing on the other side. Okay. This thing I already mentioned. Now you see 0.1. Yes.
So the left turn has less chance
What do you mean?
because this one go through and this one go through. How the left turn can go left?
Whenever he has the gap, you go at that time. The vehicles don't come like with a continuous gap, right? So maybe the one went and the other one is little bit behind. So left hand will go like this. Anyways. Okay. So you can see here these two 0.1, 0.09, very close to each other, right? And look at these two 0.33, 0.42. More difference here, right? Okay. So this one needs more time, right? Okay. So instead of putting it separately in another phase, I did what? Extended to the other phase, like it was in the previous example. Okay. After doing this, so now from here, I'll take which V by S ratio? 0.3. From here, which one? 0.51 by 0.51.
Yeah. Well, as I mentioned, 0.09 plus 0.42.
Okay.
Because it's higher than
This is how much?
0.43.
0.43. Okay. And this is 0.51. Okay. So you have to take the summation. You have to take the summation. You cannot take it separately because this is extending in the other phase. Okay. Clear? Okay. So the 0.51 from here
It's higher than
and 0.3 from here. Okay, 0.51 from that side, 0.3 from this side. Total 0.81. Okay, so we'll design for which V by S ratio? 0.81. Okay. Yeah. Now I have to calculate the yellow and all red time. For yellow and all red time, I need the dimension of the road. Okay. In this case, all roads have the same dimension, which is how many lanes? 5 lanes plus 5 feet of median. Okay, so 65 feet. All roads have same dimensions. The speed is taken as 45 miles per hour. Then this is the equation for calculating the clearance interval. Clearance interval is yellow plus all red, both. Clearance interval is yellow and all red, both. 1 reaction time for the signal. This is speed upon 2 into deceleration rate plus gradient. So gradient is 0. No gradient is given. Normally at the intersection there is no gradient. The road has a gradient, but at the intersection we keep it smooth so they can. And because the roads have different gradients, so it's much easier to keep the intersection straight, smooth. Okay. Anyways, this is the dimension of the road, and this is the speed again. Okay. So these two terms are yellow time. 1 plus this will give you yellow time. The last term will give you all red. Okay. Now in this case, all roads have the same dimension, and the speed is assumed to be the same as well. Okay. So in this case, the time will not change for any side. Okay. So this plus this is approximately 3 seconds, and this thing is approximately 1. Okay. Clear? It was little bit less than 1, so you make it 1. Okay. Clear? Then the next thing is the lost time. Lost time, we are using the recommended values given by them. 2 seconds for each lost time. You add them together. 4 seconds. The total for each phase. Okay. And if I go here, how many phases I have? How many times I have to add the lost time? 3. This plus this plus this. The rest are overlapping, right? Okay. So 3. So lost time 3 into 4. 12 seconds. Okay, 2 seconds each one of them, total 4 seconds for the phase, and I have 3 phases for which I will add. Okay, sure. Okay. Then the next step is to calculate the cycle length. For cycle length, I have 2 equations, that one and this one. Okay, we can calculate using both of them. We did. Okay. What is L? The total lost time. How much is that? 12 seconds. Okay. XC volume capacity ratio. We have to decide. Okay. It ranges from 0.8 to 0.95. It ranges from 0.8 to 0.95. Can I take 0.8?
No.
Why not?
Because the V by S ratio.
V by S ratio is already 0.81, so you cannot take V by C ratio less than that. Okay. I may try taking it 0.85. I can take it. Okay, but then they will be close to each other. Okay, we should avoid it. If we have the range, we should try to avoid it. Okay, so here it is taken at 0.9. You can go up to 0.95 as well. Okay. And if V by S ratio goes above 0.9, then you should try to play with the phasing then. Okay, do something with the demand, change the phasing plan. Okay, because V by S ratio 0.9 or higher, you will not find a suitable solution. Okay, you will put in the equation and you will get very negative values or very high values. Okay, so this will happen. Okay, XC we have to decide. We decided 0.9. In this case, summation V by S ratio we already calculated. So everything is done here. So we got the cycle length from one equation, 120 seconds, from the other equation 130 seconds. Okay, and you can see there is not much difference between the values. Okay, so in this case we have taken only 130 seconds. So the rest of the calculation is according to 130 seconds. Okay, what do we do next? First of all, we calculate the total effective green time. Total effective green time. What is total effective green time? Cycle length minus the lost time. Cycle length is 130 seconds. Lost time is 12 seconds. Okay, so 118 seconds. The total effective green time is 118 seconds. Okay.
You take 121.
Sorry. I don't know how it happens. Maybe the other slide had a mistake.
Take the average. Take the average between the two values.
Was it written the average? Maybe I wrote 130 but I didn't change the calculations. Anyways.
It's 130.
Huh?
130 will be what?
This is done by 125. Let's put 130. Okay, let's do 130. Okay, 130 minus 12 is how much? 118. Okay, then G by C ratio will be how much? Okay, they also mentioned that the summation of V by S ratio should be less than this value as well. Okay, the summation of V by S ratio should be less than G by C ratio as well. Okay, which it is. Okay, now for calculating the green time for every phase, okay, what we do is okay, so green time for every phase is the V by S ratio of that phase. So now V by S, no sorry, the total green time, let's say GT, multiply by V by S ratio divided by sum of V by S. Okay, so for example, if I'm doing it for this phase, okay, the total effective green is 118, right? So 118 multiplied by the V by S ratio of this phase, which is 0.1, divided by the total V by S ratio, which is 0.81. So how much will you get? Point? No, V by S, summation V by S. G, the 0.9 of the G by C ratio. Okay, and this one? So 118 will remain the same, this one will remain the same, you will only change this one, 0.33. How much is this?
48.
48 exactly. 0.1. Because it was 113, now we are taking 118. It's not much difference. Okay, what else? Next. 43.7. The next one, 13 point what? Same? Okay. So maybe this one is then. This one has a problem. Do with 130. Anyways. That one should be 130. Anyways. Okay. Now what happened here? We have westbound through, okay, which is overlapping with eastbound left. Okay, we have to go back to this diagram. Okay, so these two are happening together and these two are happening together. Okay, the total for these two, so this is westbound left and this is eastbound through. Okay, the total time required by them is westbound left, eastbound through. Okay, total time required by them is how much? How much is the total? 74.3. Okay, and this is happening with these two. This and this, they are happening together. So this total is 74.3 and this total is how much? How much is that? 62.6. Okay, so there is a difference of almost 8 seconds. Okay, looking at the phase diagram, there should not be any difference, right? So this one is 74 and this one is 66 seconds. But if you look at the phase diagram, they are same. Okay, so obviously this one has higher B bias ratio, so it is giving me more time. So I have to increase the time of this one. Okay, how much will I increase? The difference between them. Okay, and where will I increase? Again, I can increase here, I can increase here. I can divide them equally, no problem. I have to add 8 seconds more. I can add 4 here, 4 here, no problem. I can add 8 here, no problem. I can add 8 here, no problem. Okay, because I'm not doing it for traffic. It will not pass with the traffic. You are just giving extra time. Okay, the time according to traffic is already enough. Okay, according to the book, they are saying we add it to the through mode. Okay, so whatever 8 or 7 seconds extra we have, we'll add it here. Okay, same thing will happen in this case. This one will give you more time, this one will give you less time, right? Okay, so this is what? North through, and this is, this is northbound through, this is southbound through. So northbound through gives you more time. Northbound through, southbound through, one going down. No, it's a northbound. Northbound means going up, going in north. I'm losing 0.25 here. This should be southbound. This one should be northbound. You have to flip it. Southbound means going down. Northbound means going up. Okay, so this one should be 0.3 and this one should be 0.2. This will flip. Okay, so this one requires 43.7 seconds and this, according to this, requires only 36.4 seconds. But in the phase diagram, they are together. So there's a difference of almost 7 seconds here. So this 7 seconds, obviously now you don't have any choice. This 7 seconds will be added here. Okay, you have to make them equal. This is the thing which they did. Okay, after they did this, this gives me effective green time. I know effective green time now. I don't know actual green time. What is the difference between effective and actual?
Actual with lost time.
Without lost time.
Effective is without lost time.
Actual with lost time.
Actual with lost time. Okay. So, effective is phase minus lost time. Effective is phase minus lost time. Okay. And phase includes what? Yellow or red and green. Okay. So I know effective green time. Okay. Effective green time is the actual green time, yellow time, or red time minus lost time. Okay. this table has effective green time. I already found yellow and all red time previously, and I know this one is 4 seconds according to the standard values. Okay, so I will find out the actual green time. So what is the equation for actual green time? Tell me. G equals what? Capital G equals what? Small g minus yellow minus all red plus lost. Okay, so you take these values, the final values. Okay, you will subtract yellow or red and add 4 seconds of lost time. In this case, these values are same. Lost time is 4 seconds for all the cases. Yellow and all red time is also 4 seconds. It was 3 and 1, right? So this is 4 seconds for every phase. And you see this one, 3 and 1. So total is 4. Okay. So 4 added and 4 subtracted. Okay. So effective green equals to actual green. So this step is gone. Whatever values you have, they are actual green times. Okay. Okay. The last step is the pedestrian check. Okay. For pedestrian check, we must find out how much is time required by the pedestrian. Okay. The pedestrian time required is two parts. One is the walking time, TW, for which they have given us a range, 5 to 7 seconds. It is taken 5 seconds. And the other part was the flashing or don't walk flashing time, which was W upon the speed of the pedestrian. W for all cases, 65. The speed of the pedestrian for all cases, okay. So 5 plus 65 upon 3.5. Total is
23.5.
okay. Now this is in all directions, right? This is in all directions. So I take this value, I go back to my table for the green time, and I check it with which movements? Through movements. Okay, so you look at all through movements and check if you are not fulfilling the criteria in any direction. Okay, it was 23 point something, 48, yeah, 43, 51. Okay, so there is no problem in any direction. Pedestrian check is satisfied.
Victor, we have to compare a new value.
Which value?
59.7. Yeah.
Huh? Which value?
59.7.
59%. Yes, 59%. The final values. You compare with the final values. Clear? Okay. Okay. You may find some other examples in the book or the old traffic book as well. You will find the example. I think one of them was from the old book. Okay. So you can try it on your own. Okay. Next class we will look at the Sidra software as well. Okay, Sidra software. Okay, and we will see how these can be done with that. Okay, but you can see if we do it manually in the class, it will take more than one class to use. One example, and he doesn't bring the calculator as well. Okay, any questions? Clear? Okay.